9, 10, 11, and 12. Let's do it! Number 9, a line passing through 8, negative 15, and 5, negative 3. Hint, find the slope first. All right, well, if you want to find the slope first, you might want to measure the change in y and the change in x. So here's what we'll do. Let me turn my pen on. Good, blue pen, Johnson colors, go Jaguars. Change in x, or I'll just write my x and my y first. We have an 8 and a negative 15 and a 5 and a negative 3. Great. So we have our ordered pairs. Let's measure our change in y. Going from, what's the change from negative 15 to negative 3? If you answered positive 12, congratulations. Move to the front of the class. If you measured change in x, going from 8 to 5, if you said negative 3, congratulations. Move to the front of the class. Now that we have our change in y and our change in x, we can measure slope. M equals 12 over negative 3. 12 divided by negative 3 is negative 4. Congratulations, we have our M. Now, all we need is an h and we need a k to use our point-slope form of the linear equation. I'm going to choose 5, negative 3 to work with. So h equals 5, k equals negative 3. All right, plug and chug. I'll rewrite our equation here. Y equals m times the quantity x minus h plus k. M equals negative 4. X equals, well, that's x, that's our independent variable, minus h, which is 5, plus k, which is negative 3. So y equals negative 4x plus 20 minus 3. Combine like terms, we're left with negative 4x plus 17, and that equals y. This equation right here passes through, is the line that contains both of these points, 8, negative 15, and 5, negative 3. The answer is negative 4x plus 17. Let's keep on trucking, as if we'd ever stop trucking. A line perpendicular. Okay, remember, perpendicular lines are two lines that meet at a right angle, that meet at 90 degrees. These are perpendicular lines. So we want to figure out the line, the equation of the line that's perpendicular to y equals negative x, and it passes through 5, negative 3. Okay, so here's what we do. Perpendicular slopes. The slopes of perpendicular lines are opposite reciprocals. Opposite in sign and reciprocal. So what that means is you inspect what the slope is on your original line. Here we can see that it's negative 1. We take the opposite of that. The opposite of a negative 1 is a positive. And 1 is a poor example, but this is over a 1. What we do is we flip this fraction over so that our numerator goes to the denominator and our denominator goes to the numerator. So we flip this fraction over, which in our case doesn't change the slope. So our negative 1 turns into a positive 1. So that slope is perpendicular. So great, we found our m. Let's find our h. 5 equals our h. 3 equals our k. So we have y equals 1 times the quantity x minus 5 plus 3. Our 1 distributes to each one of those terms, or we can think of 1 times anything as that anything. So x minus 5 plus 3 is equal to x minus 2. So the line y equals x minus 2 is perpendicular to the line y equals negative x, and it also passes through 5, negative 3. All right, let's move along to the last two here. But before I do so, I just want to quickly elaborate on perpendicular slopes. Let's say we have line 1 here, and it has a slope of -5/3. And let's say line 2 is perpendicular to line 1. That's the sign for, this is the symbol for perpendicular. So this slope would be the opposite reciprocal. This sign is negative, therefore this line will be positive. And remember what I said, our numerator in our first line comes to the denominator in our second line. Remember, this is positive. And our denominator here comes to the numerator up here. So this is 3. So the opposite reciprocal of -5/3 would be +3/5. And that's how we determine what the slope needs to be when we are discussing perpendicular lines. Oh boy, computer issues here. Alright, let's move down to 11 and 12, a line that best describes each of the given graphs. Okay, well, what we'll do is we'll use y. We'll use y equals mx plus b. And so what we'll do is inspect for the b and then inspect for the m. So what we'll do is b is always the y-intercept. Here's b on that one. So b is 1, -1, -2, -3, -4, -5. So -5 equals b. And our slope, let me put my, looks like, here we go. Two and then 3. Our line is sloping downwards, so we know that our slope is going to be negative, and our rise is 2 and our run is 3. So we have our m and we have our b. So our equation is y equals -2/3 x minus 5 for this equation. This right here, this point was our b, and we just measured our slope right here. And for this line, we see that this is not a function, and no matter where we are on this line, x is always equal to -1, -2, -3, -4, -5, -6, -7. So x equals -7 completely anywhere on this line.